Alright, sit down, buckle yourselves down. We got a lot of problems to get through. Even though the actual test won't have this many problems, we wanted to make sure we had some good practice here. So make sure you get out those notes to help you, especially with the graphing. So, as usual, we start off with our horizontal asymptote first. So when there's no x up top, it's like x to the 0, right? So the bottom bigger than the top, and the bottom's bigger than the top. We know that our x-axis is where our horizontal asymptote resides. Okay? Then we simplify. Well, there's no simplifying here. It's as simple as we can get it. So, there's no x-intercepts, and there's no holes. So now we need the vertical asymptote. So we take the bottom, set it equal to 0 and solve. So we get x equals -2. Draw our vertical asymptote at -2. And all we have to do is finish our graph. Now normally the parent graph would look like this, right? But because we have this negative out front, our graph is actually going to be this blue one, and it'll look like this. Just gets reflected, just because of that negative. Reflects it over. And there's our first one. Okay, now taking a look at our second. So here we've got the same. So we take a look at the coefficients, 1/2. So for our horizontal asymptote, it's going to be y equals 1/2, which is 1/2. So up here at 1/2, draw my horizontal asymptote. Okay, then we're going to have to simplify, right? So we can pull out an x on both of those, so x times x minus 3. And on the bottom, we can pull out a 2, so 2 times x squared plus x minus 6. Now, factors of -6 would add up to +1. Oh, what if we had a +3 and a -2? That one would work, right? That would give us -6 and +1. So we get x times x minus 3 over 2 times x plus 3 times x minus 2. So now we can't eliminate anything, so we don't have any holes. We can take a look at our x-intercepts. Okay, so we take the top, set them equal to 0 separately. So x equals 0 and x minus 3 equals 0. Add 3 to both sides. Get x equals 0 and x equals 3. So at 0 and 3 we have our x-intercepts. Okay, then we take the bottom, and we can get rid of this. Take this, set them each equal to 0 for our vertical asymptotes. So we get x equals -3 and x equals +2. So +2 we've got one, and at -3. Now remember, when we have the two asymptotes especially, it's kind of like we erase that horizontal asymptote there in the middle. And that really doesn't affect us. So then our graph, we start up here, hit our x-intercept, come down. Then we know we go off screen, so we come up here on the opposite side, come down, shoot through, hit our other one, come down, and then come like this. There's our second one. Alright, let's take a look at number 3. So, same idea. We've got the same here. The horizontal asymptote is y equals 1/2, because that's the coefficient. So there's our horizontal. Okay, then we simplify, right? X squared plus 2x minus 8 will become factors of -8 to give us +2, x plus 4, x minus 2 over. We pull a 2 out, we'd have x squared plus x minus 2. Okay, factors of negative 2 that would add up to a positive 1, x plus 2, x minus 1 with the 2 out front, right? Yep. So once again, we can't eliminate any of these ones. So we don't have any holes. So we have 2 x-intercepts at negative 4 and positive 2, right? And 2 vertical asymptotes. Get rid of that, set this equal to 0, so it would be x equals negative 2. Set that equal to 0, solve it, would be x equals 1. So negative 2 and 1. So once again, you kind of don't think of the horizontal asymptote in between that. X-intercept at negative 4, x-intercept at positive 2. Okay, so I know I'm going to get going here, coming down. Okay, now with this one, there's no x-intercept here, so I know I don't cross there. So basically this one comes down and it just kind of shoots up so that it can come back up and hit that one, just like that. Okay, number 4, Samesies, so 1 over 1, so horizontal asymptote would be y equals 1. Okay, then we see if we can simplify. I can pull x's out of each one, right? So it would be x times x plus 2 over x times x minus 1. So the x's cancel out, which means we have a hole where x equals 0. Okay, we're left with x plus 2 over x minus 1. So to find the y value, you take that 0, plug it in to that one, and we get 2 over negative 1, or negative 2. So at 0, negative 2, we've got a hole right there. Then we take the top, set it equal to 0, right? Get x equals negative 2. That's our x-intercept. And we take the bottom, set it equal to 0. Get x equals positive 1, because we'd add 1, and that's our vertical asymptote. So we can see how this goes. Start over here, hit our x-intercept, go through our hole, and jump up and go around. Just like that one. Alright, let's keep on trucking here. Let's do number 6 first. So same and same, so 2 over 1 would give us horizontal asymptote at 2. Oh, y equals 2. Okay, then we simplify. I can pull out a 2, so 2 times x squared minus 1 over x times x plus 1. Now, this is the difference of squares. Remember that x squared minus 1 squared? So that actually is going to be split up as x plus 1, x minus 1. So we are going to have a hole here, because the x plus 1's will cancel. So we go x plus 1 equals 0, get x equals negative 1 for our x-intercept, or x value of our hole. Then we have the 2 times x minus 1 over x. So we plug in negative 1 for x. That would be negative 2 times 2 would be negative 4 over negative 1 would give us positive 4. So there's our hole. Negative 1, positive 4. Okay. So we take that again, take the top, set it equal to 0. So basically get rid of that 2. X minus 1 equals 0, add 1. So x equals positive 1, that's our x-intercept. And take the bottom, set it equal to 0. That is our vertical asymptote. So coming right down there. So then, start up here, go through our x-intercept and shoot down, come to our hole, and then shoot to the left. And there's that one. Now let's take a look at number 5. Okay, now we've got the highest degree up top is bigger than the bottom. That's the slant asymptote. So to figure this one out, we have to simplify as much as possible. So I can pull out an x, So I get x times x squared minus 2x minus 3 over, we can pull out a negative 3, times x squared plus x minus 2. Okay. Then we simplify that further. So we get x times x, factors of negative 3 that add up to negative 2, negative 3 and positive 1. Factors of negative 2 that add up to positive 1, x plus 2, x minus 1. Okay. Now there's none there that we can eliminate, is there? So all this extra work we did really didn't help us out. But that'll be good to know. We can find our x-intercepts, right? We've got 3 of them. X equals 0, x equals positive 3, x equals negative 1. We know our vertical asymptotes, x equals negative 2, and x equals positive 1. So positive 1, negative 2, 0, 3, and negative 1. Okay, something like that. Alright, and we don't have any holes. So now, okay, we could have simplified it to make our division easier, but it's not going to help. So, negative 3x squared minus 3x plus 6 goes into x cubed minus 2x squared minus 3x plus 0, right, to get that regular term in. So how does negative 3x squared become x cubed? Well, we times it by negative 1/3 x, which would make this x cubed. Negative 1/3 times 3 is a positive 1, x times x, x squared. Negative 1/3 x times 6 would be a negative 2x. Change the sign and add them, so those cancel. Negative 2 plus a negative 1, negative 3x squared. Negative 3 plus 2 plus 1x plus 0. Okay, so our horizontal asymptote is starting out y equals negative 1/3 x. Then, to get this to be this, we times it by 1, right? So we get negative 3x squared minus 3x plus 6. Change the sign and add them, canceled. 4x minus 6. This would be our remainder, which we don't pay attention to. So that line, negative 1/3 x plus 1, is our horizontal asymptote. So we go up to positive 1, then down 1 to the right 3, down 1 to the right 3, or up 1 to the left 3, and then we draw our line. Now you may be thinking, well, this isn't going to work, okay, because, actually draw this as an asymptote, because our x-intercept is hitting our asymptote. Remember, in the middle, it doesn't always matter, and when we have more than one, so I know that it's going to look something like this. This one's going to come up here, hit that, come back down. So then this one comes up here, hits that, and then goes toward that asymptote. Kind of flip-flops over it. And this one will come down and look like that. So, that's definitely one where you'd want to graph it to verify the look. But there we go. Okay, now we are solving equations. Now, when we look at these equations, remember, we're looking for the denominators to get the same denominator. Because then we well, not really to get the same denominator. The number that would, when multiplied, would get rid of each denominator. So I know I'm going to have an n squared, because they both have an n squared, right? And a 2 and a 6. Well, if I multiply by a 6, will it get rid of a 2? Yeah, because 6 is 3 times 2. So we want to multiply by 6n squared. So I multiply everything by 6n squared. Those cancel completely, leaving 1. cancel completely, leaving minus. Now, because this minus is in front of this fraction, it's going to be applied to the whole thing, so put it in parentheses. Equals, the n squareds cancel, 6 is like 3 times 2, so the 2's cancel, so you're left with 3 times 1, or 3. So 1 minus 5n plus 6, right, when we distribute that negative. Then 1 plus 6 is 7, so negative 5n plus 7 equals 3. Subtract 7 from both sides, we get negative 5n equals negative 4. Divide by negative 5, and we get n equals positive 4/5. Then we look back up here and say, okay, 4/5, is that going to become 0 if I put it in for n? No, squaring it would make it 16/25, and multiplying by 2 or 6 will not make it 0. So that's our answer. Okay, so now we look at number 8. So I know I'm multiplying by m squared on everything, and I'm multiplying by a 3. So 3m squared. So the m squareds cancel. 3 times 1 gives us 3, plus m squareds cancel. 3 times m, 3m. 3 times negative 6, negative 18 equals 1. So if I added 18 and subtracted 3, add 18, subtract 3, we would get 16 equals 3m. Divide by 3, we get m equals 16/3, or that would be what, 5 1/3, 5.3s repeated. Okay, which I look up here, 5 squared, 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 and times 3, not going to be 0. So those are my answer. Okay, meaning each one of these same thing, depending on which way you like to write it. Alright, so same idea here. So we've got a 2n, n plus 5, n squared plus 5n. Well, if we simplify that one, we get n times n plus 5. Okay, so if I multiply by this whole thing, I'll get rid of this, I'll get rid of the n, and I'll get rid of this. So one more thing we'll need to multiply by is a 2 to get rid of that 2. Okay, so this may be one you want to write out. So I go 3 over n plus 5 times 2n times n plus 5 equals 1 over 2n times 2n times n plus 5 plus 6 over n squared plus 5n times 2n plus n plus 5 times n plus 5. So n plus 5, n plus 5. 2n times 3, 6n equals 2n, 2n, 1 times n times 5, n plus 5, plus n times n plus 5. We'll get rid of that n squared plus 5n, so we're left with 2 times 6, which is 12. Now we simplify. Subtract n, 5n equals 5 plus 12 is 17. Divide by 5. We get n equals 17/5, or 3 2/5, which would be like 3.4. Okay, looking back up there, 3.4, no way to get rid of it, right? No minuses or anything, so that looks legit. Alright, looking at number 10. So, we only got the 3v plus 5, no fraction here, so that's what we're timesing by, 3v plus 5. Which we still have to times it by every piece, even if they don't have a fraction. So those cancel out, so 1 minus those two cancel out, v plus 6 in parentheses, and then 1 times 3v plus 5. So we get 3v plus 5 on the left side. Distribute the negative, 1 minus v minus 6. So we'd have 1 minus 6 would give us negative 5 minus v. Add 5. That would give us 10 on the left side. Subtract 3v. Negative 1 minus 4 would give us negative 4v. Divide by negative 4. and we'd get 10 over 4, which is 5 halves, negative 5 halves, or negative 2.5 would equal V. Go up here, 2.5 in here, negative would give us 6, plus 5 wouldn't be 0, so our answer works. Alright, so taking a look at 11, so we've got, simplify this one, so that would be x times x plus 4. So if we multiply by that, we'll get rid of this entirely. This will get rid of the x plus 4, leaving us an x. And then this one will get rid of the x, leaving us with x plus 4. So I kind of shortcutted that one. So we'd end up having, we got rid of all those, so that times that, so x times x would give us x squared. X times 4 would be positive 4x. Negative 1 times x, negative 1x. Negative 1 times 4, negative 4. Minus x times x would give us x squared. And think of this all in parentheses because that minus applies to all of it. X times 5 would be 5x equals, and that canceled the whole thing, so x squared plus x minus 2. Okay, so we'd have x squared plus 3x minus 4 minus x squared minus 5x equals x squared plus x minus 2. So x squared minus x squared on the left side would get rid of it. Positive 3 minus 5x would give us negative 2x minus 4. Now we need to get everything on the same side. Let's solve the quadratic. So add 4. So we get a positive 2. Add 2x. So we get a 3x. And then the x squared. And that all equals 0. So now we factor. So factors of 2 that add up to positive 3, 2 and 1. So x plus 2 times x plus 1. Set them separately equal to 0. Solve, we get negative 2 equals x and negative 1 equals x. So could those be both possibilities? Yeah. So we look up here and say, okay, if this were negative 2, negative 2, negative 2, negative 2, that would be negative 8. That would be positive 4, not 0, not 0, not 0. If we did a negative 1, still wouldn't work. We still wouldn't become 0, so those both are our answers. Alright. Hope we have time to finish all these ones. May have to make a second video. Alright, so we're going to have to multiply here by x times x plus 4 on everything. So the x plus 4's leaving us with x on the right side. And this stays the same. So I'm just going to distribute that to be x squared plus 4x. And then the x's cancel, leaving us with x plus 4 on the left. So combining like terms, subtract an x. Those would cancel. Rearrange x squared plus 4x plus 4. Factors of 4 that add up to 4, 2 and 2. So that'd be x plus 2 times x plus 2, or x plus 2 squared. Same thing. So we have the 0 is negative 2 with a multiplicity of 2. You remember that? Because of the squared. So negative 2 twice. Well, when we look up here on our x's, if I plug a negative 2 in there, it's not 0, not 0. So that's our answer, negative 2. Alright, now let's take a look at some radicals. So remember, the trick with radicals, get those by themselves. So I'd subtract 6 to get 5 equals square root of 6b plus 1. Then I square things. So I get 25 equals 6b plus 1. Subtract 1. 24 equals 6b. Divide by 6. And we get 4 equals b. Which I could plug back in there to see if it works. And it would. Because that would give me 24 plus 1 is 5. Square root of 5, 25 is 5. Plus 6 is 11. 14, it's already set up, so we just square them. 1 squared is 1. Those cancel. 4 minus x. Subtract 4. get negative 3 equals negative x, divide by negative 1. So positive 3 equals x. Plug it back in there. 4 minus 3 is 1. Square root of 1 is 1. So that one works too. Okay, then moving right along. This time we have two radicals, but they're both by themselves, so we just square everything. That gets rid of our radicals, so I've got 170 minus 2x equals x over 8. I would just multiply everything by 8. That would give us negative 16x equals, those cancel, x. And then whatever 8 times 170 is. So that 8 times 170 is 1360. So add 16x. We get 17x equals 1360. So divide by 17. We'd end up with x equals 80. And there's our answer. Plug it in, it'll work. Okay, so next one, the x's are already by them, or the radicals are already by themselves, so we square both. So we get x plus 2 equals 2 minus 6x. So add 6x. We get 7x plus 2 equals 2. Subtract 2. Get 7x equals 0. Divide by 7. 0 divided by 7 is 0. So x equals 0. So if we put 0 in there, we'd have a square root of 2. Put 0 in here, we'd have a square root of 2. So they equal. So there's our answer. Okay. Now we keep doing it. Even though we've got a variable, we still square. So we get m squared equals negative 63 plus 16m. So we get everything on the same side. Subtract 16m. Get m squared minus 16m equals, add 63. So it'll be plus 63 equals 0. Then we factor. Factors of 63 that add up to negative 16. 9 and 7, they're both negative. Yeah, so m minus 9 times m minus 7 equals 0. So basically set them equal to 0 separately, right? Add 9, we'd get m equals positive 9 and positive 7. So we go back up here, do they both work? Okay, that's what we have to try to figure out. So 16 times 9, figure out what that is. So we times 9 by 16, 7 by 16, so we get 144. 144 minus 63 is 49. Okay, so that was this one. Was negative 63 plus 112 gave us 49. Square root of 49, is it 7? Yep, so 7 checks. So 144 minus 63, gives us 81. Square root of 81, is it 9? Yep, it is. So that one checks out too. So they're both correct. Alright, 2 minutes. So, may have to do a bit of work here with a pause so we can have enough time. We've got 3 more problems to go. So this one, we square. Okay, we're going to end up with n minus 2 squared equals 2n minus 4 squared. Well, those got canceled, right? So we're going to have to multiply this. That's like n minus 2 times n minus 2. So I'm going to do a bit of work. So we multiply that out, get this, simplify it, then we're going to combine like terms. So we get n squared minus 6n equals 8, which when we factor, n minus 4 and n minus 2. Solve those, we get n equals positive 4 and positive 2. We plug them both in, they work. Okay, so I've got a minute left, so I'm probably going to work these out, then explain them pretty quick. So we square both sides, get that, multiply that out, simplify it, subtract everything, gives us this. So then we just factor this and solve. So we factored out, getting us r minus 9 and times r plus 6. Solve those, so 9 equals r and 9 equals 6. Now we got to test them. So we plug in 9 into our r's, solve it. The right side is 10. This becomes 45 plus 55, which is 100. Square root of 100 is 10, so it checks off. So 9 is an answer. Whereas we look at 6, multiply it through, we don't get the same number. So 6 is not an answer. It's an extraneous solution. Alright, so let's take a look at our last one. So looking here, you see that we square them. We end up having to multiply that ugly one and then simplify. We continue to simplify. Here's more, and your answers, and